In this video, I am going to give an introduction to integral calculus. Integral calculus is an area finding process. Here there is a regular shape, a rectangle. Finding its area is easy. You know that the area of a rectangle is length into breadth. Here B, here A. So this length is B minus A. And the y coordinate, here it is C. That means f of x is C, it's a constant. So area of this rectangle is length into breadth. So this is B minus A, then this C. So area of a rectangle easily we can find. Now we want the area under this graph. So it's an irregular shape. Now we want the area of this portion. Here x coordinate is A, here B, but y is a function of x, is going on changing. Now for finding the area under this graph between A and B, we have to use this method of integration. So this area under this graph or curve can be divided into rectangular strips of equal width. So here it is delta x. Now you find the area of each rectangle. Rectangle, you know, length into breadth. So easily you can find the area of each rectangle. This breadth is delta x and this is the length. So here x coordinate is A. So this is a function of x. So here x coordinate is A, y coordinate is f of A. So area of this rectangle is f of A delta x. This is delta x and this is f of A. This is f of A. So area of this rectangle is f of A delta x. Next, this, here it is x1. This is x1. This is f of x1. This is f of x1. Y coordinate is a function of x. So this is x1. Then y coordinate is f of x1. Then this breadth delta x. Then for this f of x to delta x. Then last one f of b delta x. So it is a 1, 2, 3, 4 rectangles. So 1, 2, 3, 4. Area below this curve is approximately equal to the sum of the areas of these rectangles. So here the gap is very much negligible. So area under this graph or a curve is approximately equal to the sum of the areas of this rectangle. Suppose you divide this into, instead of 1, 2, 3, 4, you divide it into n rectangular strips. Then it can be written as the sum sigma f of n xn instead of f of x1. Now you can write f of xn delta xn. Then summation, instead of this separately, you can write summation sigma, where n changes from 1 to n. As the number of strips increases, evaluated area will become more accurate. Suppose this n tends to infinity, this n tends to infinity, then delta x tends to 0. So now you divide it into infinite number of strips. So now the evaluated area will become, now you can see that this gap is becoming smaller. Then when n tends to infinity, delta x tends to 0, this summation will become integration. So area under this graph is now integral f of x dx, instead of delta x now dx, a to b.